So we're going to try and do an encoder alignment check on a Mote Energy ME1616. So I've started DVT, the motor's connected and it's powered on. The first thing you want to do is make sure you've got a vehicle interface window. So the little wheel symbol, if you click that, it'll open the trace window. Key parameters we need to see, ID and IQ, so that we know whether there's torque commanded, and then UD and UQ, which show what the voltage on the motor is. DVT's got a nice little control window, so we can open this, and we can select our node 1, which is our controller. We can enable it so it's ready to output torque, and then we can set a small torque demand on the motor. I can hear that the motor is actually enabled, and we can see that the IQ current is stable at 4 amps, so we know that the motor is trying to spin. We can see that there's no rotation on the motor yet, so the encoder alignment is out. So if we open up the helper, which we accessed through the little H button, there is a PMAC encoder page, which is here, and we can adjust the angle offset until the motor starts to rotate. So as we have no rotation at all, we're probably quite a long way out on the offset. So if we just keep working our way down, okay, I can hear that the motor's just started rotating now. So with our small amount of torque, the motor's now spinning up. We've got a speed limit set of 1000 RPM, just to make sure it's nice and safe. And once we're rotating, we can now use the vehicle interface up here to capture a data trace. So we can reset the trace, and then click the play button to start recording all of this data. While it's recording, what we want to do is just set the torque value to 0 and let the motor stop. So we're just waiting now for the RPM reported to go to 0, which it has now, and then we can stop that trace. Once it's saved, we can then use this handy feature on the encoder alignment to actually draw the results from that little trace. And it'll draw as a graph, which looks like this. So we've got the UQ and UD voltages. What we're looking for is UD voltage to be 0 while the motor is stopping, because if it's 0, it means that our encoder is aligned. And it helpfully tells us at the bottom here that it thinks an encoder offset of minus 10.7 will be the adjustment that we need. So we're looking to get this spread of points to be straight vertically up the axis. So if we correct it by our minus 11 approximately, and then we'll run that again. So we'll put our torque value on. The motor's not sounding like it's started yet, so I'll just increase the torque by small amounts until it does. There we go, the motor's started. And then we will capture our trace, set the torque to 0, wait for the motor to stop. Then we can save that. If we go back to our PMAC encoder, which is behind unfortunately, graph that result, we can see that all the points are now going straight up the axis, and so we know that the encoder on this motor is aligned.